Tonight we're going to be looking at section 1.7, which is on absolute value equations and inequalities. In this video specifically, we are just going to be looking at the first section, which is on absolute value equations. Now, to start off, let's ask ourselves, what is an absolute value? An absolute value is defined as the distance from 0 on a number line. So, distance means that the value that an absolute value gives you is always positive, okay? Absolute value always gives positive values. And this is because distance is a measurement that's only given in positive terms. We can't have -1 inches. We have 1 inch or 2 inches. Now, to go over the definition a little bit more in detail, it says that it's the distance from 0 on a number line, right? So the first thing you can see is that if we go 5 away from 0 to our right, this is a distance of 5. Okay, but let's say we also go 5 away from 0 to our left. This is also a distance of 5, okay? It's just 5 to the left. So there are always going to be two values of x that solve an absolute value. So since there are two values that are x units from 0 on a number line, an absolute value equation will have two solutions. So let's look at a couple examples solving absolute value equations. The first one we're going to look at says 6 is equal to the absolute value of x minus 2. So the first thing I'm going to do is, just like with every other equation, I'm going to isolate my variable. So I'm going to add 2 to both sides, and I get 8 is equal to the absolute value of x. Now, we said that absolute values always give us positive values, but the x values are going to be positive and negative. So if we look at a number line with its distance from 0, we want to go 8 away to the right, and we also want to go 8 away to the left. So my two possible values are going to be -8 and 8. So x will be equal to -8 and 8, because both of those have a distance of 8 from 0. The next example we're going to look at says 2 times the absolute value of x plus 5 is equal to 4. So again, the first thing I want to do is I want to isolate my variable. And in order to do that, with this one, we've got to isolate the absolute value. So I'm going to divide both sides by 2, and I get absolute value of x plus 5 equals 2. Again, we're looking at the distance from 0 that when you plug it into x plus 5 gives us 2. So I'm going to look at x plus 5 equals 2 and x plus 5 equals -2. I subtract, I'm going to start with the one on the left, so I'm going to subtract 5 from both sides on the left-hand equation. I get x equals -3. Then I'm going to go to the equation on the right-hand side. I'm going to subtract 5 from both sides, and I get x equals -7. So my two answers are x equals -3 and x equals -7. The next example builds on that, and now we have absolute value of 3x minus 6 is equal to 12. So again, the first thing I'm going to do is I'm going to write my two possible distance movements from 0. So I have 3x minus 6 could be equal to 12, or 3x minus 6 could be equal to -12. Because both of those represent a certain amount of movement from 0 that gives the distance of 12. From here, I'm going to start with the equation on the right, and I'm going to add 6 to both sides. I get 3x equals 18, and I'm going to divide both sides by 3, so x equals 6. Now I'm going to move to the equation on the right-hand side. I'm going to add 6 to both sides. I'm going to then, I get 3x equals -6. And then I'm going to divide both sides by 3 to solve for x, so x is equal to -2. So my two possible solutions are x equals 6 and x equals -2. Lastly, we're going to look at 24. Okay, it kind of combines all of the examples we've done so far. So this time it says 3 times the absolute value of x minus 2 minus 8 is equal to 7. So again, the first thing I'm going to do, just like the very first example, is I'm going to add 8 to both sides. So I get 3 times the absolute value of x minus 2 is equal to 15. Then the next thing I'm going to do, just like I did with the second example, is I'm going to divide both sides by 3. So I get x minus 2 in absolute values is equal to 5. And then, just like with the third example, what I'm going to do from here is I'm going to break up into two separate equations. So I'm going to look at x minus 2 equals 5, and I'm going to look at x minus 2 equals negative 5. And then from here I solve for x. So I'm going to add 2 to both sides. I get x equals 7 on the left-hand side. Then I'm going to add 2 to both sides on the right-hand equation, and I get x equals negative 3. So my two possible solutions are x equals 7 and x equals negative 3. So again, remember, like I said on the previous slide, we will always get two answers for an absolute value, okay, as you can see in all of these examples. And that is it for the first part of the 1-7 notes. Okay, so the classwork due at the end of class on Friday is page 47, numbers 5, 6, and 15 through 23 odd. And I look forward to seeing all of you on Friday.